Hello and welcome back. Today we're going to talk about Scratch move commands and the coordinate system within the Scratch environment. There's a worksheet associated with assignment. The link is in Canvas right there. I leave it up to you to download a copy of that and fill it out. As we go through this exercise, most of the answers to that worksheet will become clear. For starters, I want you to think about graphs that you have used in the past, probably in a math or geometry class. Quite often, they are set up as an X, Y grid. Very often, 0, 0 is in the middle, and X increases to the right, decreases to the left, Y increases to the top, and decreases to the bottom. That is the same as happens in the Scratch environment. This graph is in Scratch and shows that the maximum Y is 180, goes to minus 180, so the screen is 360 pixels high. Minus 240 to plus 240 leaves 480 pixels across the screen. That's the limit of the size of the screen that Scratch allows us. But if you're clever, you can find ways to make it feel or seem bigger. Positive numbers are in this quadrant. Negative numbers are in this quadrant. And then it's mixed in these two quadrants. Positive y, negative x, positive x, negative y. I'm going to shrink this and look inside the code. I'm going to ask you to explore this code and see if you can tell what the cat will do when the green flag is clicked. For starters, it's going to point in direction 90. I'm going to just show you what that means here. Over here is a direction control, and it's pointing to the right. That is 90. As I move it so that the cat is facing down, that's the angle 180. Minus 90 is upside down to the left, and 0 is straight up. It's a strange coordinate system. Normally, 0 would be to the right and 90 would be to the up, but Scratch has for some reason chosen to use the compass coordinate system, where up or north is 0. So it's what we're stuck with. So pointing in direction 90 is how most characters are drawn. So that's a good starting angle. I will retype 90 there to make sure it's exactly what I wanted. Go to minus 150, 100. Minus 150, that's an x coordinate, would be about here. And plus 100 would be right there. And in fact, you saw the cat jump over there when I accidentally clicked it. It's going to wait a second, and then it's going to go to 150, 100. Oh, that's where it is right now. 150, 100. By the way, we measure the cat from its chin. That's the center of its costume. All right, so I think we have an idea what the cat's going to do. How long do you think it'll take for it to go that distance? Well, if I just click this, it waits for 1 second, and then it immediately pops over, teleports, immediately goes to the new location. The fish has a little bit different command structure. When the green flag is clicked, it goes to minus 150, 0. That would be right there. It also waits 1 second, but it is using a glide command. It is going to take 1 second to go to the location on the right. Let's click that. It waits 1 second, and then it takes another second to get over there. So the glide command moves slowly from wherever it was to wherever the target is. Now, if the target and the starting place are the same, you won't see any motion. If I just pull this out, it's gliding for a second, but it didn't get anywhere. So make sure that you set a starting position before you ever use a glide command. Okay. Lastly, the dog. Its code, quite a bit different. Point in direction 90, that gets it facing to the right. Go to -50, -100, -150, -100 would be right there. Wait a second, and then this is a little bit different. Repeat 30, that means to do whatever's inside here 30 times. It's going to move 10 steps. Ignore this on-edge bounce for a moment, and then it's going to do a next costume. How long do you think it'll take the dog to get across the screen? Will it go faster or slower than the fish? Think about it. And here we go. Everybody's at the starting line. They all start. Interesting, the dog and the fish arrived at exactly the same time. That's because of a feature of Scratch. Anytime you have a repeat loop, it updates that 30 times a second. So if I repeat 30 times, it'll take 1 second to do all of that. The dog actually moved about the same as the fish. Fish was flipping its fin, the dog was moving its legs. That next costume caused it to do that. The move 10 steps makes us go in the direction we're pointing. And so since the dog was pointing to the right, it traveled to the right. I'm going to change the way the dog is pointing. Let's have the dog point, this direction. Now, when the green flag is clicked, the dog points up and walks up to the cat's row, but never makes it to the finish line. So, because we changed what direction we were pointing, the dog went in that direction. It moved steps in that direction instead of to the right. So the move command is sensitive to what direction you are pointing. We put that move command in a repeat step so it can slowly make it and look like smooth motion. So it slowly makes it across the screen. What happened if we repeated this 60 times? Here's where if the on-edge bounce comes into play. And there's the dog going up. He runs into the wall. Actually turned around, running into the ceiling, and headed off the other direction. So let's talk about what's going on there. First, if on-edge bounce detects if a sprite is touching one of the 4 edges. If it is, it changes the direction, just like it was a ball bouncing off of that edge. It's a handy command. The other thing is that I notice is that the dog was facing either left or right. There are 3 rotation styles. Those rotation styles, by the way, the rotation style is a motion command. It's right near the bottom of the motion commands. The default is all around, which I will do right now. I'm going to click that. And now I'm going to start it. Notice that the dog is now facing the direction it's going to travel. So rotation style all around, it points in the direction it's going to move. Left-right is the one that it was set when we first ran this. We'll do that again now. It's facing to the right or the left, but it's not going on its head. This one's more interesting if I start by pointing into 90. Let's repeat this 300 times. It'll keep going on. And set a rotation style all around. So rotation style all around. It hits the wall, it turns on its head. That looks pretty weird. And so, pointing all around is sometimes useful, but not always. Left-right is very commonly what you want when you are moving things that will be going different directions. Okay, so we have talked about the difference between the go-to, the glide, and the move steps commands. And we've talked about why the move steps needs to be in a repeat loop. I need to return these all to a good place for next time I run this program. We also talked about the 3 rotation styles. So hopefully you understand that. If not, open up this program and play around with it. Notice you can just do something like that. That's rotation style all around. Here's rotation style left, right. Oops. Oops, it didn't execute that. Left, right, it's facing left, it's facing right, even though it's going to travel in any of those other directions. And then don't rotate. Says it'll always be pointing to the left or to the right, no matter which way it's pointing as far as moving goes. So there you have it, the 3 characters. Let me just jump in your assignment. Animation is an option. If you're using the repeat and move, animation is very easy with next costume. I'm going to jump over to the dog's costumes, and you see that it has 3 costumes, and the difference is where the feet are. And so if we run with that, you can see the dog looks like it's moving. The cat has a similar pair of costumes, and most of the sprites you get out of the standard library have multiple costumes, making them easy to animate. The fish also. But let's look at the code then. How do we get that cat to keep changing? If I were to put code here to have it change costumes, well, there's no time for it to change costume. While it's waiting, we can't do anything. So in our case, we've added a separate forever loop, a separate green flag handler. And in that forever loop, we just tell the dog or the cat to change its costume. Do something very similar with the fish, except in addition to changing costumes, I've got it rotating up and down, so it's bobbing. So it's turning 1 degree at a time, back and forth, while flipping its fin. So some pretty active stuff. That has to be in a separate set of code than the wait and glide commands. Otherwise, nothing would happen while you're waiting or gliding. So you may need that to utilize those features in your final program. So the final program for this project looks nothing like the example. It's a map program, and make sure you read the instructions in Canvas for that program. And until then, enjoy coding.